Hello there, this is Alana Tucky, and I'm going to be giving you a short lecture on section 1.6, which is the design of experiments. Now, I say a short lecture because honestly, the design of experiments is truly its own course. You could take a semester just practicing designing experiments and things like that, but we're just going to kind of run over some basics. Now, the first thing we want to do is remember from section 1.2, there's a difference between an observational study and a designed experiment. An observational study is when you're measuring your response variable versus your explanatory variable, but the researcher just observes the behavior of individuals and doesn't try to influence the outcome. The researcher doesn't really have control over the people in the study, if that makes sense. A design experiment, however, is when the researcher has a control over who gets to be in what group and what treatment they get, right? What do they do to these people? What do they test them on? That kind of thing. The researchers control the people. Now, be careful. You can have controls in observational studies. For example, let's say I want to observe the behavior of students that, let me think, are very, very poor and students that are very, very wealthy, right? And then you could have like a middle control group of people that just are average income. But you're not controlling who gets to be in what group. They just are in those groups. Does that make sense? So you don't have power over the people. You don't tell them what group they're going to be in. They just are. Okay? Whereas a controlled experiment, the researcher actually decides who's going to get to be in what group, usually random assignment. And also, they're the ones that administer something to the groups. They're the ones that I give you a drug, I give you a test, I give you, I decide what you're going to have and what you're going to have to prove. Now, an explanatory variable is a characteristic intended to explain the difference in the response variable, right? So it's kind of like your x, your independent variable in algebra, is what we would call it. And then a treatment is a very special kind of explanatory variable. So there are lots of explanatory variables, but a treatment is one that takes the form of a purposeful intervention. Now, not all explanatory variables are treatments. So treatments would be things of, if you think of giving, I don't know, drugs to patients to see if it improves their outcome or whatever, then that treatment would be definitely a drug, right? But you don't have to have a treatment for it to be an experiment. And last but not least, a response variable is an outcome of the subjects brought about by the difference in the predictor variable. So it's what you're trying to look for being affected. So you want to be able to see the changes in explanatory variable, like, for example, the poverty of children or something like that. And the response variable might be their grades, their test scores, that kind of thing. All right, so let's look here. We are to determine whether the following is an observational study or a designed experiment. All right, so researchers studying people's sense of smell devised a measure of smelling ability. If you score high on this scale, you can detect smells better than others. The researchers decided that they want to determine whether women and men differ in their ability to detect smells. They gather a random sample of 48 men and 48 women and test their sense of smell. Men had an average 10.07 score and women had an 11.13 average. All right, so this is a little bit dicey, but I'm going to err on the side of a designed experiment. And here's why. The researchers are administering the test. The researchers are administering the test. In an observational study, it tends to be you're just watching what people already do. So you would just look at their test scores and know who is better, although nobody's going to take a test of smelling ability, right, on their own. But that's what it would be for an observational study. People just kind of doing it on their own. But a design experiment means you're the one that's giving them something. You're the one that's giving them a test. You're the one that's controlling what they see. It's a little bit dicey because you're not really giving these people a treatment or anything. You're just seeing if their gender changes them. But nevertheless, I'm going to err on the side of design experiment on that one. And then observational study for the next one. This is researchers from the Pew Forum on Religion and Public Life interviewed 2 random samples of people. Both samples had 1,500 people. In 2002, 645 people expressed support for stem cell research. And in 2009, 870 expressed support. Okay, Sorry, I spelled that wrong. All right, so that is obviously an observational study. All they're doing is asking them questions. That's it. That's not a test. That's not administering anything, right? So they're merely the researchers. Let me put it this way: the researchers are just asking opinions, but not administering a treatment, right? Nor controlling the groups. Right? So they're not controlling anything. They're just asking a random group of people what they think. And then they're asking another random group of people what they think. That's observational. You're just observing what people think. That's how you get at it, by asking them questions. Okay, so now let's get to some more definitions. So there's an experimental unit as the subject. That's a person, object, or some other well-defined item upon which treatment is applied. Then you have your control group. That serves as a baseline treatment that can be used to compare to other groups. Don't get confused. You can have control even with an observational study, but it's very obvious with a designed experiment because they won't be getting any treatment. They'll get placebos. Ooh, speaking of which, placebo is an innocuous medication, sugar tablet, something that looks and smells like the experimental medication, but isn't. And you make it look and smell like the experimental medication because you want the study ideally to be blind. You want the experiment person, the experimental unit, the subject, to not know what treatment they're receiving. But you also want the person they're talking to, the researcher that they get to see, maybe not the over researcher, the person in charge of the whole thing, but you want the person that they talk to not know whether they're getting the treatment either. Because if they do know, then they'll bias the results. All right, so, and again, I put that warning in there. A control group does not automatically mean that you have an experiment. So, for example, a researcher compares the lung cancer rates and records of 150 smokers and 150 non-smokers. Well, the non-smokers are the control there. But just because you have a control doesn't mean you have a control, doesn't mean that it's an experiment. You didn't force these people to smoke or not smoke. They just did it anyway. So that would be observational. All right, let's read this big paragraph. Apnea prematurity occurs when premature babies have shallow breathing or stop breathing for more than 20 seconds. One therapy for this condition is to give caffeine to the premature infants. Medical research has conducted an international study in which one sample of premature infants was randomly assigned to receive caffeine therapy and another sample received a placebo therapy. Researchers compare the rate of severely negative outcomes, death, and severe disabilities in the two groups to determine whether the caffeine therapy would lower the rate of such bad events. The caffeine group included 937 infants, of which only 377 suffered death or disability. The placebo group had 932 infants, of which 431 suffered from death or disability. Okay, so premature babies are really small and have fragile lungs, right? So they stop breathing a lot of time, and that's, of course, terrible. So what they're trying to do is see if caffeine will stimulate the system and have the baby start breathing better. And then they have a placebo group who would be touched and handled the same way that the caffeine group was. Because you want to make sure it's not just because they were picked up, or not just because they were touched, or not just because, whatever. Maybe if it was injected by a needle, then they'll inject a fake thing with the baby, like saline or something. They want to see and make sure that it's not just being touched or whatever that's causing the baby to do better. All right, so your explanatory variable, your treatment, would be the caffeine therapy. Right? You're trying to see whether the caffeine therapy, that's your explanatory, affects the rate of severely negative outcomes. Oh, goodness. Right? You want to lower, see that? You want to lower the rate of such bad events, right? You're trying to make sure that the caffeine can lower this rate. So you don't want bad things to happen to these babies. So your experimental unit obviously is the premature babies, right? And then the control group would be the babies that, I should say infants that are receiving placebo treatment, right? So they would be touched maybe, but not be given the actual injection, that kind of thing. Okay, so is this double blind? Well, the infants definitely have no idea, right? So the infants slash parents, because they wouldn't tell the parents either, because maybe that might affect the outcome, right? Do not know if the baby is truly receiving caffeine or placebo. Okay, so that's definitely blind on that end. There, I put a little bullet point in there. All right, so now to be double blind, how would that work? So the double blind would mean the doctor or nurse giving the treatment does not know if it's caffeine or placebo. And again, because they don't want to bias the results. They don't want the doctor to know, oh, I'm giving this child caffeine, because they might let it slip to the parents. The parents might be more invested in their child doing better, whatever. They want to keep it free of bias. All right, so that would, how this would work is that infants don't know. The researchers do this to keep the results unbiased, which is very important. Right? We don't want the doctor to tip the hand or the nurse to tip the hand and let them know what they're doing, because that might skew all the results. Okay, so let's move on to the next one. Hold on. All right, this is the one that we actually already read about. So it's the smell test for men and women. So your explanatory variable is gender. I mean, what's different about these two groups is male, female. The response variable is the score on the smell test. Do men score better than women or vice versa? Your experimental units would be the 48 men and 48 women given that test. And you don't really have a control group because there's nobody that's not given the test. It would be useless that way. So there isn't a control group in this case, which happens sometimes. You can do experiments that don't have controls, and you can do observational studies that do have controls. So again, be careful. Just because it has a control group does not make it an experiment. And just because it doesn't have a control group does not mean that it isn't an experiment. Which this, in other words, this one doesn't have a control group, and it still is an experiment. It's not a very great experiment, but it's an experiment nonetheless. Okay, now for this one, the researchers decide that they want to evaluate whether there is a difference in the smelling ability for people depending on whether they are sitting up or lying down. To test this idea, they gather 100 random people and and measure each person's sense of smell once while sitting, once while standing, or once while lying down, excuse me. So the explanatory variable is the sitting, lying down, right? The response variable is still that score on the smell test. Score on the smell test. You're trying to get a sense of their sense of smell. So I guess that would be the other way to say it, right? You should say, or sense of smell. Okay. Same with the one above, honestly, because the smell test, you can think of that as the response variable, or just their sense of smell as the response variable, and the score on the smell test is measuring that for you. All right, then the experimental units would be the 100 random people. And the control group, again, there isn't one because you're giving it to all of them. So why is it not likely that you're going to have blinding in that experiment? Because you can't always get blinding. You want it if you can get it. But this one's not going to have it because a person can tell whether or not they are lying down or sitting up, right? Like, how would you do that? I want you to not know whether you're lying down or sitting up. It's like, well, of course I'm going to know. So they can't be blind. So it's impossible to be blind to the treatment. Which leads me to the last bit that we care about here, which is this last design is something really special called the matched pairs design. It's an experimental design in which the experimental units are paired up. So sometimes they'll do like husband and wife, sometimes they'll do twins or brother and sister, married couples, that kind of thing. Or sometimes they'll do it with the experimental unit and themselves, which is what they did here, sitting and lying down, before and after, like pre-test, post-test, that kind of thing. It's a very common experimental design, and it's a little bit different than other experimental designs. But nevertheless, it's common, and we will talk about it more later in this chapter. As a matter of fact, in the next section. All right, so I'll see you here next time for more videos. But we are all done with section 1.6.